Now we will try to determine the maximum or minimum value by using the Hessian determinant. Now how to form the Hessian determinant? I have posted a video on the convexity and concavity in which I have uploaded the theory of how to determine the Hessian determinant. I am pasting the link of the video in the description box. Watch the video, then you will get to know how to form the Hessian determinant. Now here a function is given to us, that is the utility function, that is a function of x and y and z, and the function is given in the form as minus x cube plus 3xz plus 2y minus y square minus 3z square. We have to find out the maximum or minimum value of it. We still don't know whether this function is going to be maximized or minimized. After determining the Hessian determinant, we will get to know whether this function is going to be maximized or minimized. If the value of the Hessian determinant is negative, that means less than 0, then the function will be maximized, and if the value of the Hessian determinant is positive, that is greater than 0, then the function will be minimized. So we have to determine the value of the Hessian determinant at first. So here at first we will do the partial derivative of the function with respect to the variables included in the function. So as we can see that there are three variables in the function x, y and z. So we have to find out the partial derivatives of the function with respect to x at first, then with respect to y, and then with respect to z. So at first when we are doing the partial derivative of the function with respect to x, that is del u by del x, that will be equal to minus 3x square plus 3z. And we know that the first order condition, that is the partial derivatives with respect to the variables, are always equal to 0. So the del u by del x is equal to 0. That means minus 3x square plus 3z is equal to 0. That is our number one equation. Similarly, in the second part, we are going to do the partial derivative of the function with respect to y. We are obtaining 2 minus 2y, that is equal to 0. From solving this equation, we can easily get the value of y, that is equal to y, and the value of y is equal to 1. Now, if we do the partial derivative of the function with respect to z, we are obtaining 3x minus 6z. If we try to simplify it a little bit, then it becomes 3x is equal to 6z. And simplifying it a little more will give us the value of x, that is equal to 2z. Now if we put 2z as the value of x in the equation number 1, then we are getting minus 3 into 2z whole square plus 3z is equal to 0. By solving this equation, we can get the value of z, that is equal to 1 by 4. Now we know that x is equal to 2z from the above equation. Now as x is equal to 2z, so we can put the value of z, that is equal to 1 by 4, in the place of z. So x now becomes 1 by 2, that is 2 into 1 by 4 is equal to 1 by 2. Now the value of x and y and z are known to us, but we still don't know whether this function is going to be maximized or minimized. For getting to that point, for getting to the maximization or minimization, we have to form the Hessian determinant at first. So for forming the Hessian determinant, what is the structure of the Hessian determinant? I have written the form of Hessian determinant here. It is actually also done in the earlier video that I have linked, or that I have pasted in the description box. You can easily learn it from that video. Now Hessian determinant is equal to, is a determinant of f11, f12, f13, f21, f22, f23, f31, 32, 33. Now what is f11? For getting to f11, at first we have to understand what is f1. What is f1? f1 is the partial derivative of the function with respect to x. So, and what is f11? f11 is basically the partial derivative of f1 with respect to x. So when we have obtained the partial derivative of the function with respect to x, that is f1, we have obtained the value of minus 3x square plus 3z. Then we have to do the partial derivative of this minus 3x square plus 3z with respect to x again. Then we are obtaining the value of minus 6x. And this minus 6x is basically f11. That is the partial derivative of f1 with respect to x. Similarly, we have to find out f12. What is f12? It is the partial derivative of f1 with respect to y. And what is f13? It is basically the partial derivative of the f1 with respect to z. Similarly, we have to obtain f2, f2(1), f2(2), f2(3). What is f2? F2 is the partial derivative of the function with respect to y. What is f2(1)? F2(1) is the partial derivative of f2 with respect to x, because 1 is basically denoting x, 2 is basically denoting y, and 3 is basically denoting z. So f21 is basically the partial derivative of f2 with respect to x. What is f22? F22 is basically the partial derivative of f2 with respect to y. Similarly, f23 is the partial derivative of f2 with respect to z. So we have obtained all the values required. So now we will put the values that we have obtained, that is the values of f11, f12, f13, f21, f22, f23, f31, f32 and f33 in the determinant, and we can see all of these are basically numbers, but minus 6x is basically containing x as the variable. So we will put the value of x in the place of minus 6x, by which we are getting minus 6 into 1 by 2, that is basically minus 1 by minus 3, that is basically minus 3. Now we will solve the determinant. Now I will solve the determinant. I really feel that all of you know how to solve a determinant, but still if you don't know, then comment me below. I will try to make a video on that also. Now here I have made a mistake. The first element of the determinant, that is 3, it should not be plus 3, it should be minus 3, the first element of the determinant. Just correct it. All of the other things are correct, but just try to correct this. Now the value of determinant is minus 54, that means the value of h is negative. So we will get the maximization of the function, we will get the maximum value of the function. What will be the maximum value of function? Remember, we have determined the value of x and y and z from the first order conditions at the starting point of the solution. Now we have to put the values in the equation or in the function. So putting the values of x, that is 1 by 2, and the value of y, that is 1, and the value of z, that is 1 by 4. So putting all of these values in the equation, we are getting the maximum value of the function as 17 by 16. Now in this part we will try to generalize how to maximize or minimize a function by using Hessian determinant in a generalized way. Now here we have to take the constant as well. In the previous numerical solution there was no constant, but here we will try to generalize it with respect to the constant as well. So here the function is given as function of x1 and x2 and subject to m is equal to p1 x1 plus p2 x2. So if we want to construct z is becoming function of x1 x2 plus lambda into m minus p1 x1 minus p2 x2. How have we determined it? For getting to that point, you have to watch the previous videos of determining the static optimization with respect to the constraint. So now for getting to the maximization or minimization of the function, we have to understand how to determine the Hessian determinant. After determining the Hessian determinant, if it is positive, then the function will be minimized. If the Hessian determinant is negative, then the function will be maximized. Now Hessian determinant is nothing but it is same as previous, the determinant of d11, d12, d1 lambda, d21, d22, d2 lambda, d31, d32, d3 lambda. Now what are d11, what are d12, what are d1 lambda, and what are d21, d22, d2 lambda, d31, d32, d3 lambda, we have to determine it. Now let's go to the next page where we will determine this value of this all the element of the determinants. Now what is d1? d1 is basically the partial derivative of the function z with respect to x1. Okay, so if we do the partial derivative of the function z with respect to x1, then what will it become? At first the function of x1 and x2 will have the partial derivative with respect to x1. So I have written del x1 of fx1 x2, f of x1 x2. But in the next part we have to find out that del p1 x1 plus p2 x2 minus m. Now the derivative of m with respect to x1 is 0, derivative of p2 x2 with respect to x1 is 0, but derivative of p1 x1 will have a value of 1 if we do the partial derivative of the function. Suppose I am saying it again, if you do the partial derivative of m minus p1 x1 minus p2 x2 with respect to x1, then only the element that is containing x1 will have the derivative. And what will be the derivative? P1 will come as constant, and only x1 will have the derivative as 1. So we have obtained only p1 from the entire derivation. Now lambda is already outside and it is considered as constant, so it will become lambda p1, and p1 has taken minus with it, so it is minus lambda p1. Similarly, we have to find out d11. What is d11? d11 is basically partial derivative of d1 with respect to x1, that is f11. Similarly, what is d12? It is the partial derivative of d1 with respect to x2, that is f12. What is d1 lambda? d1 lambda is the partial derivative of d1 with respect to lambda, that has become minus p1. We have to watch the function and do these derivations or do these derivatives on your notebook, otherwise you will not be able to understand it. Now we will try to do the partial derivative of z with respect to x2, that will be our d2. Then we will find out d21. What is d21? d21 is the partial derivative of d2 with respect to x1. Then we will find out d22. What is d22? d22 is basically the partial derivative of d2 with respect to x2. Similarly, we will try to find out d2 lambda. What is d2 lambda? d2 lambda is the partial derivative of d2 with respect to lambda. Now we will find out d lambda. What is d lambda? D lambda is the partial derivative of z with respect to lambda. Okay, so that will become m minus p1 x1 minus p2 x2. Then we have to find out the value of d lambda 1. What is d lambda 1? D lambda is basically the partial derivative of d lambda with respect to x1. Similarly, d lambda 2 and d lambda lambda. What is d lambda lambda? D lambda lambda is basically partial derivative of d lambda with respect to lambda. Now, what are the values of d11, d12, d1 lambda, d21, d22, d2 lambda, d31, d lambda 1, d lambda 2 and d lambda lambda? We have obtained all the values. Just put the values in the Hessian determinant as I have put it in the form of Hessian determinant. By solving the Hessian determinant, if the value is positive, then the function can be minimized, and if the value is negative, then the function can be maximized. Here f11 will come as a value, f12 will come as a value, and all of the derivatives will come as a value when a function will be given to you. Here we have just taken a generalized function, that is function of x1 and x2. So we have gotten the values like this. But when a function will be given to you, you will get some values which are constant, and you can easily solve the determinant by those values and find out whether h is negative or positive. So this is basically generalization of the static optimization with respect to constant and by the Hessian matrix method. As this is basically, as it is a generalization, so we have taken a generalized function form, that is the function of x1 and x2. We have not written any function, any specific function. We have just taken a generalized function of x1 and x2. So this is the generalization.